So this, like I say, this is the exam from that we gave in summer 2017. There is one data file that comes with it called defects.txt. These others are files that I will upload for you to have, so that you can go through this um, after the with the exam and with the solutions. Um, for studying purposes. Okay, so problem number one is create a vector named x1. Okay, that's easy. And from 1000 to 2000 in increments of 200. So we just do a simple colon separator, and that gives us our vector space from 1000 to 2000 in increments of 200. Where did you go? I didn't do that. Um, so number B is x2 is a vector from pi with increments of pi tenths. So we're going to go for minus pi, and again, it's just a simple incrementation. And then part C is linearly spaced, named x3. So that tells us we want to use the line space, and it's going from a minus 6.5 to 2 pi with 5 values. And then the last one is a logarithmically spaced. Oh, why isn't it x4? Oh, well, we'll just call it x4 anyway. And logarithmically spaced, we use the log space, and here we use the log values. So 2 to 5 with 4 values. And so here's our spacing. So here we went by 200. Here I'm guessing that that's pi tenths. 3.1, yeah. And then here 5 values and 4 values there. To run these to check them, basically it's the same as a simple or as the M file. You have, if you're on the editor tab up here, you have the run section, which will run this section. You have the run advanced, which will run it, advance it to the next one. Or there's also the control enter, which runs, and the control shift enter runs that cell and runs the control over to the next one. And you notice that the output, because we're in the live editor, came to the live editor rather than the command window. There's nothing in the command window. You also very welcome. Okay, problem number 2. Newton's law of universal gravitation tells us that the force exerted by one particle on another is a really cool equation, not intended to be MATLAB code. The universal constant G is this big long number here, so we're just going to borrow this and set this equal to G, because we know we're going to need it. And we'll suppress the output and then make this a comment. I like to keep my units in my variable creation so that I know all my units match. Okay, find the force exerted on the Earth, by the Earth on the Sun, if the mass of the Earth is, so we'll do mass Earth is equal to 6e24, and that's in kilograms, and the mass of the Sun is we're going to borrow this so we get it right. Okay, and then now we want for values of r from, so r is going to equal okay, I'm going to do this because that's them some big numbers, so I'm going to use a line space, and we're going to go from 150 E9 to 737 5 E9, and then it wants a table, right? It just wants, so let's just give it 10 values. And this is in meters. Oops. Meters, and then let's line all our units up so they look pretty. You don't need to do all this on the exam. That takes a lot of time. It's just, a good habit to get into. And then our force equation is equal to G is a constant, so it just needs to have a single multiplier. The mass 1 and mass 2 are also scalar values, so we don't need to have but this. However, r is a vector, so we need to do an element operator, and because it's a vector, we can't divide by it without using the element operator either. And so, oh, we didn't suppress the output on one of these guys up here, so let's do that to make it look pretty. And so this dot just means that there's more numbers. Oops. See, there's 1, 2, 3, 4, 5, 6, 7, 8. There's more of them because we have 10 values in there. So if we widen that up, we can see all 10 of them. Okay, any questions? Nope. Pretty easy, pretty simple. Actually, I think this was a homework problem too. Okay, so now we're going to use the data from problem 2 and plot the values of r on the x-axis and the force of y. Add titles, labels, grids. You may need to increase the number of data points to get a good graph. Okay. It's not giving me. So I'm going to do the problem 3 up here because it's not giving me a. There we go. We hit the code button up there. That's how you do it. So I'm going to borrow these two equations here and rewrite them down here, but I'm going to give this a whole bunch more points. Give it 10,000 points, but we're going to suppress the output because we don't want to see that. So we're going to plot R versus F. And we need a title. Und we need an X label. Let's see, X is R, so that's distance. And that's in meters. And our Y label. And you notice here in the live editor, it pops up, helps for you. I mean, it's telling you what, see? Y is force. And I believe that was in newtons. And the grid. there's our nifty neat little plot. Oh, we can't have a capital G on grid. Stupid. I knew that. I just seen if you guys are paying attention. So there's our nifty neat little plot. Ouch. Ow. Oh. Any questions? Oh, stand up. Take care of a Charlie horse. Oh. Okay, so problem number 4 is use the subplot command to following. Okay, so we're starting new, and one thing you might want to do whenever you're starting with a new plot too is add a clear figure. That'll clear this before it starts adding new stuff to it. So from x is going to be 1 to 10, so we're just going to make this a global variable. Actually 0. Let's go a bunch of data points so we have a nice smooth plot. There's several ways to do these. You can okay, first one here, we're going to do y is equal to the sine of x sine x, and we're going to suppress that output. So we're going to do a subplot, and it doesn't say, it just says 4, so we're going to have 2 rows of plots and 2 columns of plots, and the very first plot is going to be this one, and in the rectangular coordinate system, so that would be just a simple plot of x comma y. Don't forget to add title and appropriate labels to each graph. Okay, so no, I just want y. So title is going to be y equals sine of x. You got too many of those on there. And then x label is x. That's wow. And then, sorry, I'm kind of tired, so I get real goofy when I'm tired. So if it's annoying, please let me know. And I don't know what I'll do about it, but at least I know I'm annoying. Okay, so there's our first plot. So now we need to do a the same thing, only now we're going to do a okay, we're going to do this another method. So we got subplot, so we're still 2 by 2, and this is going to be the second plot in the thing. We are going to, and this one needs to be a semi-log on the x-axis, so we'll do semi-log x und we're going to have our x, and on the y-axis we're going to have what, exp of x, and we don't want any optional formatting. And then we're just going to borrow this stuff here, so we're going to have to retype it all over again. Only this time is exp. You know, it'd be more gooder here if we did the type of plot rectangular, so that we know that, and then in here we could do this as sine of x. That would be more meaningful. We can't have any meaningfulness. Semilog x, and here is exp of x. And again, if it doesn't specify, it doesn't really matter. Uh, the only reason I did it this way is to show that there's more than one way to do it. You can come up here and define y as this, um, but if let's see, this better work, or I'm gonna go upstairs and go to bed. Um, what? Oh. What? Oh, you gotta be kidding me. Okay, this is a feature of the live editor that I have to have all of my variables there now. Are you happy now? Oh, see, it's happy now. See. So see, yeah. So by just putting it here, it eliminated one line of text. Is all. So you can do it either way, either define before and then put it in your plot, or define it during the plot. That was purely to show that there's more than one way to work these problems. Um, that's all. Um, okay, so for this one down here, then we're going to borrow all this, and we'll do this one the other way. Y is equal to x dot raised to the 2 plus tree, and we're suddenly plotted that only this is going to be the third plot, and go back to the y, and this one is y on the y-axis, so it's got to be a y here. And this is x raised to the 2 plus 3. And for our final plot, we are going to be in the 4th position, and we're logarithmic on both scales, so this is going to be a log with no x, and again, just to show the flexibility, we'll go 5 dot raised to the x. No, that's not right. Dot raised to the x. That looks more gooder. And this is log. 5 raised to the x. And let's hope it works. Boink. And so there's our semi-log plot. Again, I just put in here to show the different that there's more than one way to do these. That's all. Either way is correct. Okay, and this is missing a closing parenthesis. So we are going to create a table now. Oh, it is. It says yeah. See, that's the hazards of copy and paste if you don't change everything. Somebody got log log. I got log log yy. There we go. Just like it never happened. Okay, so now problem number 5. We're going to create a table with integers of 1 through 10 in column 1, log 2 of each integer in column 2, the corresponding natural log in column 3, and log 10 in column 4. So we're going to create x being 1 to 10. Y1 is, so there is a log 2 feature in MATLAB. If there wasn't, then you'd have to use the formula given here to change the log base of a number. However, because it's available, we're going to use it. So in MATLAB, log is the natural log, and log 10 is log base 10. We haven't learned inputs and outputs yet, so that's all we need to do is make a table. You can do the table command, or you can reassign the value and go x, and we're going to transpose it so it goes down, y1 so it goes down, y2 so it goes down, and y3. What? Oh, I got colon instead of semicolon. So there's our table with log values. So these are base 2, natural log, and base 10. Any questions? Am I going too fast, too slow? Okay, well then we will go on to problem number 6. Okay, so problem number 6 is the value of trigonometric functions can be estimated using a Maclaurin series. For example, the cosine of x is approximately 1 minus a whole bunch of, well, x squared over 2 factorial plus 4, x to the 4th over 4 factorial minus 6 over 6 factorial plus yada yada yada. Recall that the mathematical symbol for factorial is exclamation point, but MATLAB uses a built-in factorial function, and therefore the series can be expressed as, and then it's all gone. Create an anonymous function. So this is what you're learning in chapter 6 is those one functions. Anonymous functions called myCosine. Yes, I will put the video in Canvas for both Holly's class and mine. So if you're in Holly's class, I'll post it in a link in Holly's class also. And I'll also post the zipped file that has a blank exam, my solutions to it, and the data file. Okay, so we're going to create an anonymous function. If you haven't gotten to the chapter, was it chapter 6, chapter 7 that does anonymous functions, it is the function that is written within an M file. All the other functions, and when you're doing M file format, each have their own individual file, M file. If you're doing the live editor, then you put your functions at the bottom of the live editor. You begin the anonymous function with an @ symbol, and then you tell it what variables are going to be within your function, and then you write your function. So we're going to have 1 minus x raised to the 2 the divided by factorial 2. Now let's see, does it test your function? Okay, you we can do either or on the dot. Doesn't specify not to or to do it, so we're okay to do it. But if it told you to do it just for scalar inputs, then you would want just that's not, yes it is, x to the 4, and then we're going to minus x dot raised to the 6. You don't need that. Yeah, you do. Would you just be quiet and keep typing away? Your students want to get to bed. It's late. No, you're the one that wants to get to bed. Yes, I know. So there's our function. So now we just treat this like any other function in MATLAB. So to test it, we'll call up my cosine. No, we won't. We'll call up my cosine and pass it a value of 1, because it says right here to test using 1. And then to prove that we get the same value, we'll just have MATLAB show us what they get. And poof. And look at that, they match. Woohoo! Woohoo! Are you happy? I'm happy. Oh, I didn't include it. Oh, okay. Okay, so that's an anonymous function. Oh, here's the user defined function. I'm going to try this in the editor format. So I think if we come down here and create our function down here, so let's go up and read the information first. Okay, so create a user defined function called express, representing the following expression. So I'm going to borrow this and come down here. Now bear with me, okay? This is the first time I've written a function inside of a live editor, so I'm hoping it's going to work. So we're going to type in function, and we're going to return some output value, and it's going to be equal to something else. Let's go home and copy this so we know what we're doing. Is going to equal the name of the function, which is express, and it's only got one input, so we'll call it an x. And so now we'll come down here and give it our output. Oops, output starts with an O, is equal to 5 plus sine of x plus 2 times cosine of, only one s in cosine, x, and that's it. And now let's see if it works. Okay, and so we're going to go down here and do express comma 3, and did it work? Must. Okay, so in the live editor they have to end with an end. When you're doing an M file they don't have to, but hey, look at that, it worked. Isn't that cool? Say yeah, that's cool. Come on, say yeah, that's cool. Yeah, that's cool. Oh, thanks. So that's how you can get to have all your functions inside of one file, is to do it in a live editor. If you didn't do it in a live editor, if you do it in an M file, each function has to be within a its own M file and stored in your current directory. Oh, sorry, water break. So any questions on the function? Okay, so this tool, or this problem. Um, an oil and gas steel pipelines are inspected on a regular basis, looking for areas of reduced cross-sectional area in the wall thickness. One of the technologies used to inspect these pipelines is called magnetic flux leakage intelligent pigging. Um, I bet you can't guess who wrote this problem. These tools induce a magnetic field into the pipe and then pass a sensor by looking for changes in the background magnetic field. No, 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 this one came from me. That's what I do for a living during the day is I build inspection pipeline inspection tools. And this is actually some this file that we're using here is some of the test data that I was working on when I first wrote this problem. Okay, so and this is a good problem for those who don't know how to load data files into MATLAB with the load command. Um, we'll show you when we get. Oh, let's see. Well, it doesn't come in when we see. That's the problem with Live Editor is it doesn't load it into its memory. So I'm going to load defects.txt. See, there are oh, it doesn't have size here. Size. Okay, 430. I cut that down. There's 453 rows of data in that. So if you're copying and pasting that data file into, well, you'd have all of this data inside of your M file, and it's a real nuisance to work with. So you really, if you don't know how to load a data file, you really need to contact me, and I'll help you. Um, I'll show you how. I mean, it's really simple. You make sure that in your current folder is the data file that you're trying to load, and then in your M file, just write load, followed by the file name with its extension. And that's it. And now MATLAB will load that into its memory under a variable named with the same name as your data file. So it's really simple to load, and it's a lot easier than copy and paste, especially if you're going to sit there and write these out one by one and say, yeah, it'll take you forever. But this will do it. So now that we've got it loaded in, we can go to the next problem, which is create a vector called time by extracting column 1 from the defect data file. So to do that, we'll call up the defects, and we want all the rows from column 1, but we don't want to see them. Create a vector called data by extracting columns 5 from the defect. Oh, by extracting column 5. Okay, so there is a specific reason why I had you do column 5. What was we supposed to call this thing? Data. No data is equal to, because column 5 had the largest signal from all of the sensors. There's 8 sensors across there. So again, we want all the rows from column 5. Now we're going to plot these two, so we're going to plot time versus data. Make the line dotted, so we're going to do a little formatting, and we'll make it dotted. And give it a title. And labels. So on the X label spelled correctly will work better is time, and that was in seconds. You probably won't know this from what was given to you, but the data is recorded in what's called counts. There's so many counts per um, change in magnetic field. Um, and that should be it. And now we come in here and we run that, and we say, yay, we didn't do a CLF first. See, this is why you want to clear figures first, because see, we just wanted this one here, but it gave us everything because that was the last plot we did. So we can fix that by just coming up here and doing a clear figures and rerunning again, and we'll have a nice big plot. So you're saying, well, what does that mean? Okay, so these little dips here, that's just noise in the background. But this little blip here and this blip right here is manufactured defects that I put into a pipe. And then I run my sensors across it, and that's what we look for. Is this here is a beautiful signal for wall loss in metal based off of our tool technology. That's it. That was exam for the summer of 2017. I will, in that, in the what? In the folder that I will post with the video is summer. Here we go. So we'll get rid of this one. So here's my solutions in an M file format. Here's my solutions in a live editor format. Here is what the function would look like if it was in its own M file. And we can get rid of that. We don't need that one too. And then the data file. So I will post all of this so that you have it to look while you go through the video if you want. I mean, you know, I will also post another review exam on Canvas that I haven't gone through to give you a chance to go through it on your own. I mean, you can see I got several semesters to choose from, so I'll just grab one of them and post it as a review for you with the solutions. I highly suggest you don't look at the solutions unless you get absolutely stuck, can't figure it out, and want to go back. So, any questions, comments, wants, needs, desires, concerns, complaints? No complaints, please. I can't handle them. Yes, I will put them with Holly's class also. Now I know Holly has already posted a review for you guys. If you haven't gotten it, go look in your announcements. She posted it like Tuesday, I believe. The test begins on Monday. You have Monday through Thursday or Friday, I think. Let's look that up here. If we go to the website to look for testing, you'll come over here and pick engineering. You'll look for me for exam 1, and yep, all the way through Friday, so you get all next week to take the exam. Okay, I do have a question on Chap 6, Prac 6. I'm not sure if I did them exactly right. And let's see what Holly's... I think Holly has the same schedule. because I tried to base mine on the same as hers so that we're doing the same. She gives you an extra 15 minutes than I do, but the testing center has gotten so good at getting you up and running that you really don't need that extra 15 minutes. So yeah, she's Monday through the 16th also. So um, okay. What's your question on the practice exercises? You do know that the solutions to the exercises are on Canvas, right? You have access to them before you do. If are you in Holly's class? Oh, you're in my class. Okay, so if you come to the home page here and come down here to assignments and practice exercise solutions, the solutions are right there. But so what's your question on 6.2? Let me find my textbook and I will. MATLAB for engineers, practice exercises. 5, 6, 6, 6, 6, 6.4, 6.3, 6.2. Okay, assuming the matrix dimensions agree, create a MATLAB function to evaluate. Okay. So is there one in particular? Okay, for Holly's class, if you go to your main web page, come under the same one, only she just has it labeled assignments, and scroll down to the bottom, practice exercise solutions. I made it a little easier for my students. I labeled it better on the front page and brought them up to the top. But that's where the solutions are for the practice exercise. Not a problem. Okay, so yes, each one would have to be done as a separate function. So you'll have multiple inputs on the first 4 and 2 outputs on number 5. Do you know how to do that? So there is that option there, new. It'll bring this up. So if you have multiple inputs, you just put them in on this side in the parentheses, I can speak, separated by a comma. And if you have multiple outputs, you'll put them inside of square brackets on the left side of the equal sign. Now, just be aware that when you do that, and you call this function, if you assign the output of your function to a single variable on your main script file, it will always report the first output. But if you assign it to 2 variables, it'll give you both of them. That's pretty much the case on the max and min. If you assign the results from the max function to 1 variable, you'll get the maximum value. If you assign it to 2 variables, it'll give you the maximum value and the location within the vector or matrix where the maximum value was found. Clear as mud, right? Just okay. So you mentioned that you can convert an M file to a. Okay, so let's say I have this here. This is an M file. It's a function, but it's still an M file. Um, it's actually it's going the other way. You can take a live editor file and save it as an M file by doing a save as and do an M file. Um, no, because it already exists, so it won't take it. So I'll give it another. So now it's opened up as an M file. So it's no longer in a live editor. If you want to change an M file to a live editor, you right mouse click on the title block up here and do open as a live editor. And then you have the choice of the output coming to the right. See, if you run this, the output comes over here to the right or underneath. And I like underneath. Does that answer your question? Oh, I guess we're done. I can unmute you guys, so if you can talk if you want. Unmute.
Everyone else is now unmuted.
Boy, that was loud. Okay, so you guys are free to speak now. I've unmuted you. Somebody's laughing at me. Okay, I'm going to